Okay, so now what we're going to do is we're going to, yesterday we took the nth roots. Now what we're going to do is we're going to add, subtract, multiply, and divide expressions with radicals, okay? So when you add radicals, it's kind of like when you add x's. So let me show you what I mean by that, okay? So you don't have to write this down, but I just want to show you. Do you guys have that written down?
Yes.
Okay. So if I gave you x plus 5x plus 7x, could I add those all together? Why? They all have x's. Perfect. Okay, what is the number in front of this x? So 1 plus 5, 6 plus 7. So my answer would be 13x. Okay, so square roots kind of work the same way. You can't add square roots unless the number underneath the square root is all the same. Well, I know you're looking at this problem and saying, well, we can't do that because they're not all the same. You're absolutely right. But some of the times, we can take the other square roots and simplify them, just like we've been doing in the past. So can you simplify the square root of 3, or is it simplified all the way? So we're going to bring the square root of 3 down. We can't do anything to that. We're going to bring the addition sign down. Now we're going to try to simplify the square root of 27. By doing that, I'm looking for two numbers. When you multiply, you get 27. What is it?
9 and 3.
Okay. Do I need to circle either one of those? 3. Okay, 9. Can I circle any of those? Okay. Now I'm looking for a pair. Do I have a pair?
Yes.
What do I have a pair of?
3.
So that 3 is going to go on the outside. Bless you. And then what about this circled 3 that it doesn't have a pair? Stays in the radical. Okay. We're going to bring this addition sign down. And now we're going to simplify the 48. What are two numbers you can multiply to get 48? What is it? Okay. What are two numbers you can multiply to get 6? Two numbers you can multiply to get 8. And then 2 and 2. Do I have any pairs there? What do I have a pair of? Do I have another pair of 2s? So what do I do with those two pairs? And what is 2 times 2? And do I have anything left over that needs to go into the square root? Okay. Now, do they all have the same number underneath the square root?
Yes.
Okay, so just like the x, remember, what did you say this number was? Even though it's not there, what is that number?
1.
That works the same way here. We have 1 square root of 3. So this is 1 plus 3, which is 4. 4 plus 4 is
8.
and that's our answer. You don't add the square root of 3, you just leave it. What questions do you have about that one? Any questions? Okay. Now we're going to multiply a couple things together. Okay. These look the same, right?
Yep.
Okay, what's the difference?
We get 8 on the fraction.
One is minus, one is plus. How did I get the 8? We're going to go back to example 1. Because in front of this there is a 1. 1 plus 3 is 4. 4 plus 4 is 8. So that 1, you don't ever see that 1, but it's there. Okay. Did that answer your question? Okay, so one is negative and one is positive, so we're back to example 2. These are called conjugates, okay? We're going to use conjugates in parts in example 6, but I'm going to teach you how to multiply them now. Okay, so you have two things. It's just like if I gave you, if we go back, remember when we used to do this? And we used to FOIL? It's the same thing. We're going to do that. So we're going to do 2 times 2, which is 4. Then we're going to do 2 times the square root of 7, which is 2 square roots of 7. Then we'll do negative square roots of 7 times 2, which is minus 2 square roots of 7. And then we'll do the square root of 7 times the square root of 7, which is minus the square root of 49. Now, what do you notice when you get there? These are going to cancel out. So anytime you multiply conjugates together, you guys, those two middle terms are going to cancel out. And then you're going to be left with 4. Well, what is the square root of 49? So 4 minus 7 is, and that is your answer. So remember, these are conjugates. Conjugates are going to get rid of any square roots, and that's why we use them when we use them in the fraction, which I'll show you in example 6. What questions do you have over examples 1 or 2?